Hi folks, Tom McNamara here, back for our course in Prep for College Math. Since we have moved on to working with integers, in other words working with positive and negative whole numbers, I thought it might be nice to look at a chip model again to help us understand why some operations work the way that they do. Now, if we're going to represent signed numbers with chips, we're going to have two different colored chips. So I'm going to use blue for positive chips and red for negative. So every blue is going to count for positive one, every red is going to count for negative one. Now, when we're doing these representations, we have to understand that there are multiple ways to represent any number. Okay, there are multiple ways to represent any number. So for example, if I wanted to represent the number positive 3, let me go ahead and write that in a different color than what my chips are. Let's see, how does the green show up? Okay, that doesn't show up too bad. Okay, if I wanted to represent the number positive 3, one way I could do it is with 3 positive chips. Simple, right? But I could also do it with 4 positive chips and 1 negative chip. Okay? So if we have a positive and a negative chip in the representation, they kind of cancel each other out. So this is yet another representation of negative 3 with 5 positive chips and 2 negative chips. So that is going to be key to understanding how this chip model helps us figure out why the rules for signed numbers work the way they do. So, when we are adding signed numbers, let's do a quick example of adding signed numbers with the chip model. And let's do something like 3 plus negative 5. Okay, now we discussed in an earlier video that this would work out to be negative 2. Okay, and I just kind of told you that and hoped that you believed me. And the reasoning was, well, we look at these two numbers, we see they have different signs. The 5, the negative 5, has the bigger absolute value. So the negative number wins, so our answer is going to be negative. And when we have different signs, we subtract. Now, if we use the chip model, we can actually see why this works out to be negative 2. Because when you're doing the chip model, here's what you start with. You start by loading 3 positive chips into your model. Oh, can we really, looks like it's kind of right there. Light's kind of shining on the 5 a little bit. So you start by loading 3 positive chips into your model, and then you add these chips to the model. Okay, so I'll start with my 3 positive chips. 1, 2, 3 positive chips. And then I will add 5 negative chips to this model. 1, 2, 3, 4, 5. Okay, now, with what we just talked about, with different ways to represent numbers, and how having a positive chip and a negative chip kind of cancel each other out, these 3 sets here of positive and negative, those all cancel each other out, and what are we left with? Negative 2 chips. Okay? So this chip model, I hope, can help us understand why the sign rules for dealing with addition of integers work the way that they do. Let's do another example. Once again, we'll do one with mixed signs. Let's do negative 4 plus negative 2, okay? Okay, no, I said I wanted to do one with different signs. So negative 4 plus 2. Okay, well, we'll follow the same principle. We will start with 4 negatives, and then we will bring in 2 positives. That gives us 2 pairs of chips that can be canceled out, and we're left with negative 2, which is just what we would have seen in following the rules that we discussed in the last video. These numbers have different signs, so we look at which number has the bigger absolute value. The negative 4 has the bigger absolute value, so the negative wins. The answer is going to be negative, and we would subtract. Let's do just one more, and then we'll move on to some subtraction. Let's do negative 3 plus 5. Okay, so once again we'll start with this, putting negative 3 chips there, 3 negative chips, 5 positive chips, and we can see here those cancel, and we are left with 2 positive chips at the end. Okay? And once again, if we follow the rules from the last video, we're seeing different signs. The positive 5 has the bigger absolute value, so the result is positive, and we do 5 minus 3. Okay, so what I'm hoping is that the chip model helps us understand why that works the way it does. Remember, the whole goal in a class like this is to understand why these rules work, not just what the rules are. Okay. Now, if I'm doing subtraction with signed numbers, I think this model really helps out a lot. Because if we're doing subtraction, you might have heard that if you're subtracting a negative, that becomes addition. Okay, and you might have trouble understanding why that should work that way. So let's do a couple of examples here. Let's do 3 minus negative 2. Okay, 3 minus negative 2. So if I'm going to do the chip model, I would start with 3 positive chips. Okay, just like with addition. Okay, we start with whatever's here. And then take away 2 negative chips. Now this is where you might say, well, Dr. Mack, that doesn't sound possible. Oops, that's 3 negatives. I'm supposed to start with 3 positives. 1, 2, 3. You just said start with 3 positives. Well, where are the 2 negatives for me to take away? Now, if you go back and look at the beginning of this video, you'll see that we had different ways to represent an integer like 3. We could represent it with this, or we could represent it with this. This is 4 positives, 1 negative. That's another representation of 3. Or the 5 positives and 2 negatives. Now going here, we can actually see in this representation we can take away our 2 negative chips. So we get rid of those. Those go away. And we can see that 3 minus negative 2 should be 5. Okay? Hence, when you take a negative and you subtract that negative, you actually end up adding. Because to subtract that negative, you've got to represent your starting number in such a way that you have enough negatives to take away. And the only way to do that is by throwing in the corresponding positives with those negatives and then taking away those negatives. Okay? So, let's do one or two quick examples here. One or two quick additional examples of doing subtraction with signed numbers. Okay, so if I was to do, let's do a negative here. Let's do -2 minus 5. Okay, something like this. -2, take away 5 positive chips. Okay, so once again we'll start the same way. Load in -2. So I load in 2 negative chips. Now I'm supposed to take away 5. Take away 5 positive chips. Well, I can't do that with this model right now, but I can do it if I change the way I am representing -2. Namely, if I represent -2 in this way. If I represent -2 in such a way that I can take away 5 positive chips, we'll see what happens. So I do -2, and what I had on the board really was a representation of -2, because remember, every time we put a positive and a negative, they kind of cancel each other out. Now the whole point of doing it this way is it gives me 5 positives to take away. And look what I've got: -1, -2, -3, -4, -5, -6, -7. So -2 minus 5 is -7. Okay? So hopefully this can help you make sense of the sign rules for addition and subtraction of integers. So I think it's a really helpful setup. It's called the chip model. Of course, if you're dealing with signs, remember you have to do 2 different colors of chips. One color to represent positives, one color to represent negatives. We talked about a chip model earlier in the course, and we only had one kind of chip because we were dealing with whole numbers. In other words, just positive numbers. We hadn't brought in the negatives yet. So here we do need those 2 different colors. And remember, there are multiple ways to represent any given number. You can always throw in a pair, a matching positive and negative, and get a new representation of that same number. So here, if you want to take -2 and remove 5 positive chips, you've got to represent -2 in such a way that it has the 5 positive chips for you to take away. Okay? So a handy little way to look at these operations.